Hello everybody, I'm Travis Reeder and this is Reed Allman. We're with Iron.io. We're going to talk about our experience with Docker after launching 500 million containers. A little bit about what Iron.io is. We have two products. Our first one being IronMQ, which is a cloud message queue running on multiple clouds and now also on premise. And Iron Worker, which is a asynchronous processing as a service, so basically a task queue. And I'll dig a bit more into Iron Worker. I'll give you the deets. So Iron Worker, basically you write code that will do a specific task, something small, transforming an image or moving data, that kind of thing. And that's basically your worker. In a typical work environment, that's what you'd make. Difference is you upload your code to us, to Iron Worker, and then you queue tasks, or millions of tasks. And those tasks will run across thousands of machines, and these all run inside Docker containers. While these are running, you can go make coffee, maybe do your taxes. It's a good time for that. Either way, you're a happy camper because you didn't have to manage all this infrastructure. So that's Iron Worker. A little background. So before 2014, early last year, this is pre-Docker, we were using LXC, which is kind of what Docker was originally based on. But that was Linux containers, which was fine. It worked. But we had a single one-size-fits-all container. And the problem with that was all the components inside it were getting old. So we had Ruby 1.9, Java 1.6, Node 08, and people that used us couldn't pick newer versions. So a lot of customers couldn't use us because of this. And it was hard to upgrade as well. We couldn't upgrade these runtimes. We couldn't upgrade even Linux libraries sometimes because we'd risk breaking people's code that was already running on our servers. And so basically it just never changed for several years, actually, until Docker came along. And so the main reason we started using Docker was to solve that problem, and it did that quite well. So we ended up making new stacks. We call them stacks, which is basically a Docker image with newer language environments, newer libraries, newer OS libraries, and we can keep upgrading these things and tag them, and the tags are basically our stacks. We couldn't do that before, believe it or not. So yeah, as a user, now you can choose your stack. When you're running, you can say, I want Java 1.7, or I want Java 1.8, or Ruby 2.1 kind of thing. And a side effect of this is you can actually test your stuff locally on the exact same environment that it's going to run in the cloud. This was also pretty difficult to do before. And so before you could run it locally, you'd upload it, and maybe it didn't work. Now you can test it locally, upload it, and be sure it'll work. And of course, the good things that come with Docker and LXC give you this too, but isolation between our users' code. We're running code that we don't know what it's going to do. We don't know if it's going to try to break our machines, but luckily this will prevent them from doing that. We can ration out resources like memory and CPU between our users. And the layered file system makes us so we can have all these images based off our Iron base image and add all these new images without taking up huge amounts of space, which also saves a lot of time when we're deploying and that kind of thing. But it hasn't been all roses, and I'm going to pass this part off to Reed.
Yeah, so I get to say bad things now. So we had a problem where basically Docker was hanging out with Carl and it got bit. And so it turned into a zombie, and for us that means that basically all the tasks that were on that machine were not even going to be able to terminate, and then we couldn't launch any more tasks, and then we couldn't even get like a Docker status because the Docker daemon is just dead. And so there's a trivial fix. You just have a little bash script that runs and sees if you can get Docker help, and then but it's not so fast because we have to we can't reap it, right? So it's a zombie and it's Docker and it's big and it's bad, and Neither of these guys. I think we gave up after these two, and there's more init systems in the Great Debian Wars that came along, but we kind of gave up. And then, so we're just kind of screwed, and we have to reboot the entire server to get all those tasks running back. So we get, our capacity goes down a lot, but we've kind of figured out how to mitigate this, and they happen a lot less frequently now. But for a while, it was kind of scary. And so then you have Pen is at Cry, and he doesn't even have Bamboo. He's very sad. So other things are, we advertise a Phantom stack for a lot of people, and Phantom has more issues than they've figured out, which is interesting. And then also Docker has issues, but Docker has figured out a significant portion of their issues, but they still have a lot of them. And so then they get together and they put all their issues into one room, and it leads to bigger issues. So the big issue there was that not necessarily that Docker is an issue, or not necessarily that Phantom is an issue in itself, even though it has plenty. It's that when you combine the two, you run into issues that you wouldn't otherwise run into. So if you run our Phantom task on a normal Linux server, then it runs totally fine, and it doesn't lock anything up. And so why is this any different in a Docker container? If you want to figure that out, please. That's just kind of a side effect of using Docker, is that you run into problems that you otherwise really shouldn't. And so actually in doing this, we've learned that debugging Docker is not very fun either. Even though we all like yelling at computers, they're extremely frustrating. Because so Docker is Docker, and it's Linux, and it's your Linux, and there's a lot of your Linuxes running on your Linux, and so you don't really know whose Linux is whose Linux. And so it's really hard to debug when you have kernel panics. You don't know if it's Docker that's causing the kernel panic, or you don't know if it's Linux causing the kernel panic, or you don't know if it's Docker because another Docker is over there that is causing the kernel panic. So alternatively, maybe we have some mental health issues. And so we have some wishes, which recently came true. The stats for observing what is happening in Docker land are awesome, which came out yesterday. And then we would also like to see kind of like stack traces and maybe, which Linux is going wrong. But we just kind of would like better debugging tools because we've wasted a significant portion of our life that we'll never get back on debugging Docker. And then Swarm also looks really cool for us because we're running all these tasks and we don't really know beforehand how much like RAM somebody wants to use or how much CPU somebody wants to use. So if beforehand we didn't stick them conveniently on a server where 29 RAM hungry people were, then that would be really nice for us because you could get all your CPU time over there. CPU sharing isn't really great for these things, so we're like really looking forward to resource-based orchestration. I don't want to say buzzwords, but I have to say that one. So we're also using this, and this is the regular expression language. It's horrible, but this means the other places that we're not using Worker, and so we use it now for build containers. So we use Docker to build Docker containers, which is interesting at first, and then when it finally works and it's magical, it's really nice because you don't have to have servers laying around just so you can build against all the different versions of glibc that people decide to use on their operating systems that have been supported for way too long. And so deployment, we use Chorus and Fleet a lot, mostly for the message queue thing. And those are really nice. They're convenient because they do all the service discovery stuff for us. And that's just a Go binary, so we totally get a huge benefit from just sticking it in a Docker container, which is really easy, and we get all these benefits. So we like that. And then mostly for the on-prem stuff, we're working with customers where they give us a machine and we have to run on it. And a lot of them, like Red Hat Enterprise Linux 6, and Red Hat Enterprise Linux 6 doesn't have the greatest version of glibc on it. And so now we can just run Docker containers on there, which has the right version of glibc, and everybody can be happy. And so, cool. Now, I think we left enough time for questions. I don't know.
What could you not do on LXC that you can do on Docker? Making the images in the stacks was a really nice thing that LXC didn't, well, they didn't have the tooling for that, period. So, I mean, that's the original reason why you started using Docker, and a lot of this other stuff's kind of side effect to that. But yeah, we could contain things and limit memory and CPU, which was what we used LXC for in the first place. Yeah, I mean, LXC wasn't perfect either. We filed kernel bugs because of LXC being broken too, and some of the stuff is probably LXC related or libcontain. Could be. And another thing too is we're running a system that's atypical, I think, from most people. We're running, millions of tasks, and they might last for a second or 5 seconds, whereas most people will run these containers for long periods of time. So we're spinning them up and shutting them down all day long, kind of thing. So I think we find issues that may not be found in other cases. Thank you.